welcome to ClusterSeven and Protiviti webinar entitled Model Risk Governance, You Need a Wider Lens. In this session, we will cover how organizations can manage their financial models holistically, the regulatory impact, the best practice approach to managing data quality, the impact of poor data on financial modeling, and how technology can support robust model risk governance. Today's webinar will be co-presented by Colin, Director, Risk Analytics and Model Risk at Protiviti London, and Henry, Vice President of Sales at ClusterSeven. We will have Q&A at the end of the webinar, so please send your question over via the question window in the GoToWebinar screen. I'm now going to hand over to the presenter.
Yes, hello, and thanks, Melanie. I'm Colin Farquhar. I'm the Director of Risk Analytics and Model Risk for Protiviti in London. Protiviti works with financial institutions globally across a wide range of models, but mainly in the risk analytics and pricing model space. Be that building such models, validating them, or looking at model reviews and audit. As part of that, we encounter all sorts of technology issues and end-user computing issues. We work closely with ClusterSeven to tackle some of those.
Hi, this is Henry. I'm a VP at ClusterSeven. ClusterSeven, for those of you who don't know, is a leading provider of end-use computing software. We're pleased to have a number of the leading banks, insurance companies, asset managers, as well as energy trading companies as our clients. We have been recognized by a number of the analysts for our technology. The ClusterSeven technology is best of breed. Most recently in the risk tech charted risk tech quadrant, ClusterSeven was recognized as best of breed in the model risk governance solutions in the marketplace. So we welcome you here today, and I'm just going to hand over to Colin to start this webinar.
Well, thanks, Henry. So since we're going to be talking about model risk governance, pretty good starting point is to think about how we define a model. That may seem obvious, but actually when you get into it, it's slightly non-trivial. So for today's discussion, the definition we've come up with is a model refers to a quantitative method, system, or approach that applies statistical, economic, financial, or mathematical theories, techniques, and assumptions process input data into quantitative estimates. It also covers quantitative approaches whose inputs are partially or wholly qualitative or based on expert judgment, provided the output is quantitative in nature. So models are effectively simplified representations of real-world relationships among observed characteristics, values, and events. That definition drives a lot of what else we do, and if you think about it, you'll find it's fairly all-encompassing, and most of the characteristics you could think of analytical systems would be captured by that definition. Now, in practice, what are the sort of models we look at? Obviously, there's numerous different things come to mind across many industries, but today we're really thinking about financial institutions. And Protiviti works with those institutions across many areas, some of which you can guess, some of which perhaps are less obvious. So we've got a sort of sample that completes the sort of things we do. Starting off, we've got the usual trading book, derivative and other financial instruments, pricing and valuation models. You're thinking of swaps and credit default swaps and all the whole plethora of derivatives which pop up. Some of that modeling can become quite complex. Related to that are securitization models, and the many forms. There's cash flow models and there's waterfall models. We need to go into all of the details of that, but we could be handling very large data sets, quite complex models for these structures. Also underpinning a lot of financial institutions, and of course many financial institutions, i.e. banks, and effectively credit houses, are the credit decisioning and underwriting models. Now that's related to the few I've put on the list after this, which would involve things like credit loss modeling, so default, loss given default, exposure at default models, leading on to the whole portfolio management process. How do you model, instead of on a single obligor basis, how do you look at the risk and the diversification of risk across the portfolio? Also, in recent years, of much higher scrutiny or operational risk, all the sorts of things that can go wrong in day-to-day operations, and any of those could be technology-related, business process, as well as environmental, operational risks that can arise and catastrophe risk. And many of these models for banks and for insurers, the ultimate aim is to figure out how much capital you need to hold to keep the institution solvent. You all know what happens when that goes wrong. So many of the models I've just discussed feed into models of economic, regulatory capital, driving capital adequacy, and obviously the large stress testing programs, which are looking at how financial institutions will cope as the state of the markets and the world environment changes. Probably of all the things in recent years, that's the one getting the highest level of scrutiny. We've done a lot of work with ClusterSeven, many of the models and their implementations in financial institutions. There are other risks associated with trading. We touched on derivatives earlier. But there are second-order effects and market risk. You have market VAR models, and you've also got issues to do with the details of modeling around about convexity, and obviously credit risk in the trading book, which is effectively counterparty exposure, that can all become fairly complex. That leads on to financial reporting, and about balance sheet reporting, credit value adjustments, debt value adjustments. You're reporting on exposures in the trading book, and since obviously markets move around, those exposures are moving around on a day-to-day basis. That can all get fairly tricky. There's lots of end-user compute tools floating around in those environments. And then finally, we've got asset liability management, where, as the name implies, you're trying to balance off your exposures on the asset side with your liabilities. Try and match those. You don't have an underlying, or at least you've managed your underlying net exposure. Okay. There's lots of regulations in progress in the pipeline. You probably heard of Basel III and Dodd-Frank post the financial crisis. It covers many things like liquidity risk, credit risk in the trading book. Then you've got fundamental review of the trading book, which is leading to a truly huge number of models at desk level in banks, and there's interest rate risk in the banking book as well. So the whole model space is growing. There's lots to do. There's lots going on, and there are many underlying issues. Now, when we're doing this modeling at clients, we regularly see the models implemented in all sorts of end-user tools as well as central risk engines, and we regularly call in the help of ClusterSeven to try and bring some form of order to that process.
Well, I guess, Colin, you've introduced a term here that may not be familiar to a lot of people. This end-user computing, it has many acronyms, and user-developed applications, business-managed applications, user-developed applications. Fundamentally, the term has grown due to the pressures on the organization. You spoke very eloquently earlier, Colin, about the additional need for models, the modeling required within the business to make sure you understand the implications of world events on that organization, ensure that they have adequate capital, the increased reporting that is required. And what you're finding in organizations is the IT systems really cannot IT cannot maintain those IT supported systems or keep on developing them quick enough in order to meet the requirements of the regulators, but actually more importantly of the business itself, to ensure in this ever increasingly global market that they are running profitably and within the mandates that they've been given. So what you've seen in order to fill that gap between the requirements of the business and what IT systems can support is the growth of end-user developed applications. That's also come with the advent of more powerful desktop computers where people can actually use and use desktop applications where previously you had IT solutions. So what you find in the marketplace is, I think sort of on the screen here we have a number of the core applications used to develop those models and those reports. So things like R, Python, MATLAB, in terms of modeling side for some of the reporting, ClickView, business objects, and our old favorite Excel as well, where they're being used effectively to fill that gap between the requirements of the business and what the IT solutions can provide in order to be able for the business to run and maintain that business, to go into new markets, but also to be able to report that back to the regulators. Speaking of the regulators, they're also now focused on this activity. So within all of these familiar regulatory frameworks, we're increasingly seeing end-user computing being referred to. I mean, I guess the summary of all of these regulations is that what the organization should do is recognize that some of their processes would rely on end-user computing. So at its core, there should be an inventory of all of those key end-user computing assets, but then to ensure that there are adequate controls, so that you actually understand how they're functioning and how they're performing within the organization, and ensure the integrity and the accuracy of the data that flows through those. And that's the data flows and accuracy is something that we will explore later within this webinar. So I hope that gives you a bit of a 101 on what EUCs are, their importance within organizations, and particularly the modeling issues that organizations are facing. I'll pass you back to Colin to give you more about the model framework.
So I thought it worth saying a bit here of what all is involved in terms of the model governance frameworks. Again, that's not entirely obvious at first sight. Many different things come into it, and end-user computing figures in a lot of these things. So just think about what would be involved. I've got about 8 things around this wheel. Now, the first one we spoke about earlier, which was the model definition and criteria. Well, that was important. That links on, if we jump ahead to position 4 in that wheel, which is the centralized model inventory. And obviously, how you define the model determines what gets onto the inventory. Now, these inventories, years ago were actually quite small. They've been increasing in size as more and more spreadsheets and analytical tools are identified as models. So that's a good starting point. You need to, at the very least, know what you have somewhere and have that centrally agreed as to what constitutes the models in the organization. Related to that, though, but also the policies and procedures around about how the models are built and how they're used. I mean, gone are the days. It's a bunch of model builders building it, validating it themselves, implementing it themselves, and then the business side going ahead and simply using those. There are many more controls round about that. There's much more separation between the build and validation teams, and there's a lot more focus on use tests and are the models being used for what they're meant to be used, and also as the business or the external environment change, such that those models are no longer applicable. And of course, part of that is thinking about what do you mean by applicable, because nothing's ever 100% accurate. So at what point do you say things are working sufficiently well, or no, we've got to go and do something different? So there's a whole bunch of things around about policies and measures and procedures. And related to that are the standards. So it's a case of developing, we're listed here, model development standards. There's also validation and implementation standards, as worth mentioning here. And in terms of what becomes acceptable. You don't want to be rebuilding everything on a daily basis, but nor do you want to have a situation where the model methodology or particular implementation has become stale, is no longer representative, but nevertheless still potentially driving a lot of business for the institution. So that is an interaction between the different stakeholders from the business and the risk management, as well as the modeling side, to come to an agreement as to what constitutes a good model standard. Sometimes it's better to have a slightly less accurate model, but one which is more adaptable and hence flexible across a wider range of situations. So many things come into that. Related to that is a risk ranking methodology of the models themselves. Some are obviously more material than others. Some you don't need to worry about too much, even if things go wrong. Well, it's not going to impact too many things. Others, it's extremely serious. I mean, you misprice a swap, for example, you do that on a consistent basis, you rapidly find yourself having, huge exposures. And there's been many historical industry examples of that and related things happening, which always seem obvious after the event, but before the event, with everything else going on, never quite so obvious. So there has to be attempts made to rank the materiality of the models and also to keep that up to date, because obviously as the external environment changes, so might the materiality of the models. Related to that is model validation techniques. So as models become more complex and varied, there are numerous different ways to validate the models, and as well as that, not just the analytical piece being validated. I think as Henry touched on earlier, it's also the implementation and the interactions and how those models are implemented. And the model development techniques obviously are connected to the things we discussed earlier around about the development standards and what constitutes acceptable model performance. That's connected to the reporting side, because obviously many of these things can get extremely technical, but much of the audience is non-technical. One of the challenges the industry faces is how to interpret all of that model validation output in a way which is meaningful to the end user, such that they can understand the key points and therefore know when they might be running into problems with using that model, perhaps outside the schema for which it was built. And there's a lot of interest in this. Reports for regulators are getting extremely complex, and much of that is quite a complex technology problem as well, because it's aggregating data from risk engines and data sources all around the institution, often making group level reports to regulators. And the final point in this wheel obviously is the change process, which is, once you decide, first of all, how do you decide that things need to be changed, and when do you do, how do you manage it? I mean, simply changing things suddenly can lead to issues, and that leads to a sudden jump in capital. Is that real, or is that just due to some artifact of the modeling? And if it is, we need to understand it. So we need to understand real physical, real world changes vis-a-vis changes which are occurring purely because of changes to the modeling process. There's a lot of scrutiny in terms of what's being changed and how it's being changed, and also trying to harmonize that. Obviously, if you're looking at a portfolio right across an institution, you've got bits of that making changes to their model methodologies and infrastructure which are different to other parts of the organization, then you have a problem. So trying to harmonize that group-wide, which all sounds very simple, is nothing of the sort. In reality, there are all sorts of subtleties comes in. A lot of the work we do at Protiviti is working with organizations in terms of reviewing what they do there, in terms of that whole model review and change control process. There are a few other things come into it. Roughly, that's pretty much what covers the model governance piece. And behind that, as mentioned, there's a lot of technology, a lot of end-user computing, and every part of this wheel. There are things captured in desktop databases, and spreadsheets, and statistical software packages, financial engineering tools, and so on. And they can grow into the many thousands. So, as well as the sort of conceptual challenge and methodological challenge, actually turning it into something that's operationally usable and well understood is non-trivial. I thought it worth mentioning here, because Henry spoke earlier about the plethora of regulations around the globe, a large part of which are connected to modeling issues and risk analytics. Fairly recently, the European Central Bank has introduced what they call TRIM, where TRIM is the targeted review of internal models, and a lot of that covers the things we've just discussed. It's particularly focused at so-called regulatory Pillar 1 models. Those are the models which are being built to measure your credit, market, counterparty, operational risks. They're important because they ultimately drive the risk-weighted assets of the institution, which in turn drives the capital. So that's what's there to protect the institution against unexpected losses and to, as best as possible, ensure the institution remains solvent when things go very wrong. Of course, what the ECB is concerned about is obviously institutions need to hold different amounts of capital because their portfolios are different. But of course, they may find that we could come up with two identical institutions and find that nevertheless, apparently, they're reporting different capital. And that could be due to subtleties in terms of the way they're measuring their risks or doing their modeling, the way it's implemented. So if we can improve the governance industry-wide and across countries, then we've got a more level playing field, and it's easier to have compatibility between financial institutions, and also for regulators and governments to have more confidence in terms of the stability of the financial system. So there's obviously a high level of interest in getting this right. So it's largely focused on those models driving the RWA and capital requirements. Now, the last time I looked, it was estimated there's about 13,000 models, around about 6 to 8 banks in 15 countries across Europe. So that's a lot of models to be reviewed, and one suspects it may well be an underestimate. People go looking, they're going to find there's actually many more. There's also worth bearing in mind, as well as the core model engines themselves, there's also all of the infrastructure driving that, and increasingly regulators are looking at everything round about the models, looking both upstream in terms of the data sources feeding the models, lots of end-user computing tools holding the data there, and looking downstream in terms of model use and reporting. So my guess is that number is going to grow greatly in reality in terms of what's actually material. It's worth mentioning here that the United States has had a lot of model risk guidelines around really longer than Europe in terms of the OCC SR 11.7 model risk guidance, and there does seem to be a fair amount of similarity between TRIM and SR 11.7. I think, as you'd expect, a lot of it is about these model governance things which you discussed, especially that model governance wheel, which was the subject of the previous slide. Now, the outcome of all of this is clearly going to be increased focus on model governance, model risk, institutions tightening the model risk management, and a large part of that is going to be improving data flows, improving the IT systems, getting more clarity in terms of where these models reside. It's all good stuff, and I think it's pretty self-evident that the outcome of it is to drive similar standards and hence compatibility across the industry. So I think there's a recognition that that has been perhaps lacking in the past. Now, I thought it worth here saying something about the whole model life cycles. Tend to focus a bit too much perhaps on the pure build and validation aspect. So without going into this in too much detail, I've come up with a couple of flowcharts, both pre and post model implementation. So, for the analytical people in the audience, they'll be familiar with all of this, but for the less analytical, perhaps there's not always an appreciation of what's all going on behind the scenes. So we start off with what we call a model request. In reality, it tends to drop out of a real business need. And from that, you've got the initial design, which is deciding on the relevant methodology and how that's going to be built. Then actually gathering all of the data to do the model development itself, as well as the pre-implementation validation and the final selection of the model. Now, run through those quickly, because in reality there are numerous feedback loops. I mean, sometimes you've got to go right back to the beginning and redo the whole methodology because things come to the light and you do the validation. There's an interaction going on between all of these things. And of course, the model development and validation teams are actually separate in practice. And I've got to, the validation team's job is to challenge what the model developers are doing. So again, there's a lot of technology involved, a lot of model implementations floating around in different tools. And you've got the challenge of getting those to talk to each other and pass data between them, make sure the data is clean and representative, and so on. But finally, you go into implementation, into production, and of course, we're not done then. That goes to post-implementation, where that kicks off, in many ways, an even more complex flowchart, where there's ongoing performance modeling of how the model's working, by the model owners, but actually by the business units using the models themselves. And also then you've got to think about what we touched on earlier, which is, well, at what threshold does model performance, when it drops, become unacceptable, or maybe even just be a temporary phenomenon. So you need to think about when is it that we actually need to think about realigning the models or recalibrating them, or perhaps doing a total rebuild. While that's going on, there's also periodic model validation, which is usually at least annually and sometimes more often than that. And that feeds into part of the decisions as to whether or not the models require to be revisited. Then there's the third line of defense, which is independent audit. That a lot of that deals with those process things. Is everything being done properly? Is there independence? Is there a similarity of standards across the organization? And that tends to lead to a periodic model review board, which looks at those models which an institution is using with the view to deciding, which ones and prioritizing which ones need to be recalibrated or rebuilt, and also giving the reasons why. That brings us back to pre-implementation, and the whole process starts all over again. So there's obviously a huge industry around doing this. It's growing all the time, and the technology complexity is simply rising. And just before I hand back to Henry, it's probably worth saying, and it is an important point, we just touched it a little earlier, the whole scope of what we're looking at has greatly grown. It's not purely about the model engine. It's also about everything upstream and downstream from that. And that very quickly pulls in a huge number of IT systems and of IT tooling, often which is distributed around, sitting on people's desks, and in a multiplicity of environments. So I'll hand over to Henry to say a little bit about that part of the problem.
Yeah. Thanks, Colin. I mean, I guess I echo the challenges that you talked about. We see that within our clients. I guess it comes to the title of the webinar, the widening of the lens. Traditionally, in the last few years, we've seen the model governance concentrating mainly on those model kernels, the methodology around the creation, the appropriateness of those models for their use, and the methodologies that Conrad explained earlier. And that's gaining some level of maturity. I guess it depends on the organisation you're talking about. And what we're showing you, Victoria, here is that upstream, downstream, and embedded within those models is a dependence on external feeds. We talked about end-user computing earlier. The predominant end-user computing tool of choice seems to be Excel, but there are others, as we discussed earlier. What we're seeing is that model governance piece growing and encompassing more of the upstream and downstream systems or tools are being pulled into that governance framework. And a key part of that, as we said earlier, is trying to understand the data lineage, trying to understand the provenance of the data, where it's coming from the organization, ensuring that it is the appropriate data that should be fed into the models. But also then downstream is ensuring that you have this perfect environment in which the calculations are correct, the data is being used correctly, but then all of those assumptions and calculations are being invalidated by some manipulations on the output before being given to regulators, clients, senior execs. And I think it's important for organizations to recognize that these frameworks are reliant on additional tooling that sits on the outside, and ensuring that that data, the understanding of that data lineage is becoming more and more important for organizations.
We thought at this point it's probably worth pointing out the sort of top 10 issues which we encounter in model governance. I mean, there are others, but it tends to be a recurring theme with most clients. You're right at the top is the incomplete model inventory. I think for the industry as a whole, this is still a work in progress. Some institutions, I think, are probably just roughly done. Others are close to getting started. And of course, it defines how you've got to define what you mean by done. It's a sort of moving target, as we discussed earlier. But deciding what was on that model inventory and then finding things which are not on it, that pops up a lot. The other, definitely the second most important, be around about data constraints. That's always an issue when building any form of model. But often it's not that the institution doesn't have the data. It relates to it being scattered around in end-user tools. And a great deal of my own model build team's time is spent aggregating that data and cleaning it up and sorting it out. So there's certainly scope for efficiencies there in terms of improving that process. Inconsistencies in modeling approaches, so that comes down to methodologies and the nuances of how models are implemented. There are many things to think about there, and that comes back to what we're saying about trim earlier and trying to get some form of consistency across the industry. Unrealistic assumptions, well, everybody tries not to do this, and often with hindsight things seem unrealistic, but there's now a lot more scrutiny really in terms of justifying any form of modeling system contains assumptions, and these really is a lot of regulatory scrutiny to properly understand that. And that of course relates to then understanding where the model can be used, which is when it doesn't violate the assumptions. Model version and tracking, many end-user tools, models sitting around, tracking can all get a bit of a mess when there's thousands of models and business pressure. So a lot more focus on having proper version control and how each of those models are implemented, where they're implemented, and understanding how they've been implemented. Model accuracy we touched on earlier, but the key point there is having consistency in terms of performance testing, really exception flagging so that you can understand when the models are not working properly, or even if it's not the modeling, the IT infrastructure which contains the models, somehow there's an issue there, bringing that to the fore. Effective challenge, I think that's improved greatly over recent years between the three lines of defense, which is having independent validators and independent model reviewers challenge the model build team, and also challenge the business in terms of how they're using the modeling infrastructure. Vendor models, of course, when the model's built by somebody else, then you've got a second issue there, which is how can you be sure that it's working properly for yourself if you haven't built it. Doesn't mean to say you shouldn't use vendor models, but it does mean that there's a particular approach to validation. Sometimes there have been shortcomings with that, which come to light later in terms of issues with the model usage. And then understanding the actual, how the model is implemented in the software functionality, how to use it in practice. It would be the first time everything's been built properly. It's only as good as what goes in, and if nonsense goes into it. But if the software isn't very clear exactly how it's all being used, then nonsense comes out of it. It can sometimes take a while before anybody spots that. So again, my background to good control of the end user compute environment. Just a quick summary in terms of the scale of this, the sort of trends we're seeing globally across the industry. The large banks are seeing inventories with 3,000 roughly models, and if anything, that's growing. It's including more and more items which are effectively what you call end user compute, sitting on traders' desks. One-off analysts' models are increasingly finding their way onto these inventories. There's a lot more focus, and as mentioned earlier, on the data lineage, which is what's actually driving the models. Are we sure about the quality of that data? Regulators getting very interested in that. A lot of regulatory reviews now include a big piece on data governance. You might have heard of ECBS 239. There's a lot of that with group-wide data governance and the aggregation of risk data. And there's a large argument that if you get that right, it's much easier to get the modeling right. But of course, that's a complex problem. You're dealing with legacy databases, spreadsheets, and so on, with data scattered around the organization. So many clients are hiring chief data officers to try and get a handle on that data and compute environment round about the modeling. Just worth saying here, just to summarize how model and end user computing governance is converging, is an example from our team in the United States doing some DFAS, the Dodd-Frank Act stress testing project, and that's very much stating loud and clear the model inventory should also include significant end user computing applications. So that's very much formally bringing in these EUC tools into the stress testing and validation environment. And here's a quote from a CDO from a large financial institution who tells us we're increasingly seeing spreadsheets being reclassified as models. We're also increasingly seeing model governance principles being applied to such end user tools. And indeed, the same CDO told me he has thousands of instances of such, and it was particularly operationally a difficult problem to tackle. So worth leading on now to say, well, how can technology help with that?
So thank you, Colin. Just trying to pick up some of the threads that Colin laid out there, as we see there's increased scrutiny from the regulators ensuring that you have good model governance. The lens is widening, so more things come into scope. And there's clearly an increased workload from that. So we've observed a lot of this, and what I hope to do in the next 5 minutes is just to try and explain how the technology solutions from ClusterSeven can help organizations bring some clarity to that and bring some organizations to some of the issues Colin raised. So the first thing that I guess to bring to the table is what can technology do? And I guess we define this in 3 key buckets. There's an ability to understand do the discovery, to understand the scope of the issues that face the organization, to pull that together all those files into an inventory, as Colin said. What is key for an organization is to have that model inventory in one place. That inventory should include not only the core models, but also the end user computing that model environment relies on, whether as a key model or as dependent or downstream reporting requirements from that modeling environment. And where end user computing is playing a key part, and those are key models, is spreadsheets and other end user computing applications can be changed by the users, by their very definition. And what technology can do, or what ClusterSeven can provide, is a change tracking, so you can understand that the model that you signed off at your last model committee, that spreadsheet that is providing a core feature of your model environment, is still the same model that you're running the following month. And if not, what changes have been made, and ensure that the changes have been agreed by the committees that approve such changes. So we concentrate just on the discovery piece to begin with. There is still, and this goes back to the regulators, a belief in some C-suites that the IT systems talk to each other, and all these model environments and reporting environments are all controlled by IT. And really, what the discovery does is allows you to clear that fog, to start getting an understanding of what I describe as this halo of end user computing that sits around that modeling environment. One of the best examples of an output from the ClusterSeven technology is, again, drawing together all of these themes, but looking at the data lineage. So it's not uncommon for a model to be fed by a one or a number of key end user computing applications, so a spreadsheet that's pulling together information that feeds the model. So in this case, this is one of 3 files that was feeding a capital model for calculation. What the organization, the regulator, are driving to is, what's the provenance of that data? So what the technology is able to do is to interrogate that file, so pointing up the ClusterSeven technology at it, interrogate that file. It provides another dimension to the analysis that Colin talks about. We talk about having a materiality of each of those files. What the technology can do is also provide a technical assessment of that file. So we can grade each of those end user computing files in terms of their technical risks to the organization. And the other thing the technology looks for is, what are the dependencies? So this one file at a first level is actually dependent on 26 other files. Again, these have been assessed at their technical complexity. In this case, the rules we've run it against red means it's broken, those green clearly not. But it doesn't end there. Those files themselves are dependent on others and others, and it's not uncommon for us to find this sort of spider, we call this a spider diagram, this web of dependencies that are flowing up into your core model. Now, we've met organizations that are trying to map this out manually, spending many man days, if not months, trying to map this out. And what you've got to understand is, by their very nature, this could change by this afternoon, or by tomorrow this picture changes. So what technology does is allows you to be able to very quickly establish or understand those data flows, and then be able to try and mitigate or change that in order to make sure you have a robust framework in place to ensure the data flows into the model correctly. So, yeah, as I say, it's not unusual for us to find, people will understand the 1 or 2 key models, key dependent EUCs. What they don't know is all of the underlying dependencies that it has. So from that discovery capability output and working with Protiviti, what you're able to do is basically come up with your inventory to capture that inventory. We provide an inventory tool. You can capture the materiality of those files based on your risk appetite. Added to that, you add in the technical complexity, and as I mentioned earlier, for those spreadsheets that are deemed critical, you are also able to track the changes, understand how that model is evolving as required by the business, and ensure that any of those changes are validated. So there is a 4i capability within technology to capture the reasons for the change and the verification that change is correct. So I guess that's a very brief summary of what the technology can offer. I guess in the real world, what does that mean? Trying to tie together what Colin talked about and how the technology, what the technology can do. What we have is an example here of a project that ClusterSeven and Protiviti worked on. This was at a GSIB where we were looking at some of the stress testing processes. The organization recognized that there was quite a heavy reliance on end-user computing, or specifically Excel, within that organization as part of their stress testing process. They engaged Protiviti to look at the policy, to define a policy around the use of end-user computing, roles and responsibilities. They helped collect a manual inventory from the organization, and then what we were able, and added the materiality weighting to that. And what ClusterSeven was then used to do was to add that technical dimension to it. And then for the materially high, those files materially high, there was then some remediation done by Protiviti. Those files were captured within an inventory stored within ClusterSeven, and then a complete audit trail and version history of all of those files was maintained by the ClusterSeven application. And when significant changes were made, that whole review and approval process that I described earlier was enacted as part of an operating model designed by Protiviti for this organization. That just gives you one, conscious of time. There's a couple of other case studies. Talking to an organization that was looking at building out stress testing models in SAS. They used Excel as a prototyping tool, and they were using ClusterSeven to help with the model development. So as the model evolved, they were using the technology to track those changes. They then recognized there's an 18 to 24-month process to migrate those models once signed off into SAS. So whilst they were being run operationally, again, ClusterSeven used, as the previous example, to track and understand how the models were evolving. And there is a suspicion that not all of those models will end up in SAS, and Excel will be the place that they remain, and therefore ClusterSeven will be there to manage those. And I guess that lays into the last little note at the bottom. We are coming across a number of smaller organizations, so some, for example, challenger banks in the UK, where actually Excel is the environment they want to run their models. They're very comfortable in building and developing, and they have actually no appetite for buying third-party modeling tools. Some of that may be financial, and really what they're utilizing, the organizations in question will be looking at Protiviti to provide some validation that those models are fit for purpose, and once signed off, the ClusterSeven technology will remove any operational risk around misuse of that file, or ensuring that any changes that are made to that model are understood, have been documented and agreed. So I think that ends. We'll hand back to Melanie and just see if we've had any questions in at all.
Yeah, thank you very much for this very interesting webinar. So yeah, we'll now open the session for any question you might have. So we had a couple of submissions during the webinar, which is great. So I'm going to start with the first one. How is internal audit involved in model risk?
That's one for me. Yeah. Well, increasingly, as we mentioned, the three lines of defense earlier. I think historically, if we go back several years, it tends to be model build and validation, and audit was less involved. But increasingly now, so there's so many other factors around about process, and the process of how the models are actually built and used, but also everything round about that. A lot of demand is being put on audit departments to scrutinize and provide independent feedback. You're seeing them having a lot of power in the process, which has led to interesting challenges, of course. Typically, they perhaps had less analytical people in such departments, but now you're seeing analytical people working right across three lines of defense, and also, I mean, Protiviti works in terms of model review with the audit department. So they're now really a key part of the process. They don't sign it off, then the model's not going into use.
I mean, I agree. I mean, where we see internal audit increasingly get involved, where EUCs are involved, calling into question, how those models are being used, are they being used appropriately, how are changes being changes to those models, how can we ensure that they are being done correctly, that people are signing off to the veracity of those changes. I think the interesting thing with MiFID II coming, increasingly in sort of, for example, models used for high frequency trading, there's going to be additional scrutiny required around actually understanding and validating that the models are correct and importantly check any changes, but also obviously to be able to produce evidence when scrutinized.
Great. We have another question, which is, how do you see the three lines of defense work together and maintain independence?
For me again?
Again.
Thank you. Yeah, well, that independence is extremely important, I think, which is having the challenge between the validation team to the build and then the audit team challenge both of the other lines and be completely separate. Regulators very much look for this. It does introduce operational challenges, and this is a huge exercise in so many models, and effectively 3 different lines going on. So an interesting theme here, just probably worth mentioning here, is many institutions looking for efficiencies here. Just say, yeah, they want the 3 lines working separately. They also want to find ways of sharing the technology or data, not necessarily each team replicating, completely reinventing the wheel. Just looking for operational efficiencies. But yeah, that independence is extremely important.
I mean, I guess I've got a slightly different observation or an additional observation around 3 lines of defense. I think, as I said earlier, I think audits are, from an end-user computing perspective, are all over or increasingly aware of the significance of end-user computing and the issues it can cause the organisation. I think the first line are also aware that there is a dependence, and until the IT systems can catch up, they're always going to rely on that. I see in a lot of organisations second line not stepping up. So what you do find is audit giving trading desks and others audit points in and around the use of end-user computing, and we need to see an increase in the responsibility taken by the second line.
Great. So I'm conscious of time, so we will take one last question. All unanswered question, we will come back to you individually. So this question is about quantification of risk. There is a lot of work there, so how do you prioritize?
This gets down to the ever-growing model inventory. It's great to have a model inventory, but there's a lot of work to maintain it all. This is actually a really large topic in model risk management right now, which is how do you rank order the risk of the models themselves and their materiality. And there are a number of quantification systems being developed to do that. Effectively, just a heat map of your organization, so you focus your efforts in those areas where you're most at risk of issues arising from model risk problems. We do a lot of work with clients, and some interesting things going on. So effectively, think about it, a lot of it's qualitative things. So how do you turn that into a quantitative measure, which in itself validatable? Several layers of validation going on here, such that the senior management can direct resources towards where they'll have most effect.
What ClusterSeven provides from an inventory perspective is the ability for an organisation to capture that qualitative information, for them to then be able to define a quantitative scoring from those questions. But also, I think importantly, to add where it is end-user computing, the technical dimensions. So you can through that qualitative approach, you can come up with a materiality score. What the technology can do is then add an additional dimension and provide I guess, a baseline against how technically risky each of those files are. If you're a quant trader, you may think a simple spreadsheet to someone else is a very complex one. So just having a baseline to measure that against is important. But again, one thing that Colin and I were talking about before this webinar is the other thing you've got to consider is that some of these models which were low materiality 3 months ago may actually grow in significance, and capturing that recertification of the materiality is a key part of that model governance process. And what technology does is help you ensure that the frequency of that recertification is maintained, and therefore, what was previously low materiality is now high materiality is understood by the organization as a whole.
Great. Well, thank you very much. Thank you, Colin. Thank you, Henry. Thank you to all the attendees this webinar. So we are going to end this session. As I said earlier, all the non-answer questions, we will come back to you individually. And I will send you a copy of the presentation after this webinar. Thank you.